702 and Cape Talk.
The Naked Scientist.
Hello, Chris.
Good morning.
Chris, we have millions of people already calling in to ask you questions, but I am very keen on our science story pick of the week because cholesterol gets a bad rep, and you are going to tell me, I think, about the importance of distinguishing between bad guys and good guys, particularly in relation to recovery from certain heart conditions.
That's right. Heart attacks kill about 1/3 of people, and they also don't kill a very significant number of people, but they do leave them disabled by having a damaged heart, and they're at high risk of developing what's called heart failure, where the heart can't keep up with the demands of the body. Now, one way to treat this is a heart transplant. That's going a bit far. The other way is to try to prevent heart attacks, but we can't prevent all of them. So how can we limit the damage done by the ones that do occur? When a heart attack happens, it occurs because a blood vessel supplying the muscle of the heart has become blocked, and this starves the heart cells of oxygen and sugar. So they can't remain viable. Well, there's a very interesting paper by Sarah Hayward, who's a researcher originally from the Baker Heart and Diabetes Institute in Melbourne, Australia. She's now working in Copenhagen. But what she has managed to do is to use cholesterol, the thing we usually regard as a bad thing when it comes to heart disease, to rescue hearts damaged by a heart attack. So what they've done is to look specifically at a form of cholesterol called HDL, because cholesterols are not all made equal. There are forms of blood cholesterol which are bad, they're called LDL, but then there is another form of cholesterol called HDL, high-density lipoprotein, and that's judged to be good for your health. So what they've been doing is in small groups of mice, they have triggered a heart attack in these small groups of mice, and then they've given them an infusion about half an hour later of HDL cholesterol. And there are a couple of products actually in clinical trials that enable you to do this because it's being actively explored in the clinic for various reasons. And what they find in these mice that receive the infusion of HDL cholesterol is that the damage done by the heart attack is much smaller. In fact, the scar left on the heart afterwards is maybe 20% smaller. The hearts also beat and produce 10% more output in the post-heart attack period. They show much less scarring and fibrosis and injury to the heart afterwards, better development of blood vessels in the heart afterwards, and they're much better at using sugar. What they think is going on in this Science Translational Medicine paper that they've published this week is that they think the HDL cholesterol binds to a receptor or a chemical docking station on the surface of heart cells, and it triggers a similar pathway to the insulin signal that normally controls blood sugar. And what that does is it makes the heart cells much better at grabbing glucose from the blood and metabolizing glucose to release energy. And the reason heart cells die during a heart attack is because they run out of energy. So if you encourage them to use glucose better, pick up glucose better, and make energy from glucose better in the short term with this dose of HDL, then that should encourage more of these cells to survive the insult of the heart attack and give you a better post-heart attack outcome. And they're saying it should be relatively easy to translate this to the clinic because these products already exist, so now we need to move it on and do a clinical trial. But it could be an entirely new way to try to manage heart attacks and reduce the damage that they do when they occur.
Lovely, 13 minutes after 10. Mark in Centurion, what question have you got for the Naked Scientist?
Yeah, other guys. A quick question. I know how rainbows are formed by the reflection of light and the reflection back of the sunlight in water droplets or vapor through the air. But my question is, why is the rainbow actually curved? Why is it not like a horizontal band across from left to right? Why is it actually curved in a beautiful arch? Why do you sometimes get two rainbows? And why have I never seen three rainbows on top of each other?
What a lovely
Wow,
cluster.
Mark, there are more questions than there are colours in the rainbow almost. Good morning, Mark. Okay, first of all, let's deal with why are rainbows the curved shape that they are. Well, you're right that the reason we see a rainbow is because of light reflecting from raindrops. So here's how it works. Remember that white light coming from the sun is a mixture of different colours of light, which when they all hit our eye together, the experience we see is white. Now, when those light waves go into a raindrop, because different colours of light have different wave lengths, they're slightly different sizes or lengths of waves, they bend a bit when they go into the raindrop, and each colour bends by a different amount. So that's why you split the white light up into its individual colours, because you get rays of light of different colours coming off at slightly different angles from the back inside surface of the raindrop, which looks like a mirror, and then it sends the light out towards your eye, and that's why the light is split up into bands. Now, why is it an arc? Well, actually what's happening is that when the light is coming out of the back surface of the raindrop, it's coming out like a cone. So actually you're seeing a circle of light being reflected at you, but in fact some of that light is hitting the ground, it's not hitting your eye. And so you end up with a circle which is cut off to make a rainbow because the Earth's surface is in the way. If you were to see a rainbow high up in the sky from an aeroplane, for example, you would see a circular cone of light of all these different colours coming towards you. Now, in terms of why the light is in the order that it is, as I explained, different wavelengths of light bend by different amounts, and that splits them up. But some of the light that is reflected off the back inside surface of each raindrop comes straight out of the raindrop again and comes to you. But some of the light reflects off the front inside surface of the raindrop and makes the journey inside the raindrop again. And so it's now bouncing off an additional mirror, and that inverts the light again. So you then see a second rainbow at a more spread out angle with the colours in a different sequence. But because only a fraction of the light has done that, it's much dimmer than the first rainbow that you saw, which has got the vast proportion of the light coming at you. There is possibly a third rainbow and a fourth and a fifth, but there's so few photons or rays of light left doing that they're invisible up against the contrast, the bright light that's already there in the sky, so you can't see them.
Okie dokie. Nao, good morning to you.
Hi, Eusebius. Well, naked scientist, just a quick one. Look, I can understand why we've got, the Ghanaian English accent, you've got the Sesotho English accent, us adopting the language. What kind of boggles my mind is, with the Australians coming from Britain and going to America, how is it that the accents are just so extremely different? You can tell that this is Australian, this is American. When what I know is, they came from Britain or the UK. Is it because they came from different areas in the UK? But, the accents are just so vastly different. And will we have the same kind of accent today in Australia, say, 100 years from now? Obviously, there could be wars or whatever. But
I love that. Yeah, great question. Thank you, Nao. Chris, why have you guys not exported one accent?
Well, it's interesting. You guys are busy exporting accents, because when I go to Perth in Western Australia and do sort of science shows there are loads of people who come up to me and say, I listen to 702. And I said, well, you're in the wrong continent. And they say, oh, no, well, I live here now. And actually, I think it's good. It's really nice to hear a South African accent up against the Aussie accent from time to time. It's really, really nice. The reason these accents got started is because in the pre-internet era, can you imagine there was this time when there was no Facebook? People were much less connected. We had far less of a mobile population. Industry was close to your home. You lived and worked in almost the same place. There are people certainly in Britain, but in many countries, who live and never leave and work in the town that they were born in. And as a result, they are immersed in the local culture there. And this means that because people are social species and we all learn off each other and we imitate each other to fit in, that's why we get on well with each other. And where do we learn our language? We learn it from our parents. We are immersed and patterned from a very early age to behave how our parents behave and how our neighbours behave and so on. That meant that there was, because of geographical isolation, an opportunity for certain ways of behaving and speaking to become focused in those areas and selected for. Also, if you know how someone sounds, then you know where they're from. And in the days of people, not getting on so well, when people were, America was trying to disappear off and divorce itself from Britain, and the British weren't very happy about that. Actually, having your own identity and your own accent is quite a good way to distinguish you, wasn't it? And it's true across all of the 50 plus countries in Africa. People who speak a certain way, and there's a tribal thing to this. So in the early days, that was part of it. People getting geographically and isolated from each other, and they stayed in small communities, and that meant that certain traits became very ingrained. These days, that is changing. The mere fact that you and I are speaking, and I speak with a different accent to your accent, Eusebius, the fact is the world is now much more connected, and we are exchanging culture, we are exchanging language, we're exchanging words, and we're seeing words from different cultures cropping up more and more and more in different vocabularies. And people are changing the way they speak. People are now studying this. They're showing that television is changing the way that certain accents work. And someone wrote to me from America a few years ago now, and they said that they downloaded our entire catalogue of Naked Scientist podcasts, because we were one of the first podcasts ever. There's about 1,000 episodes of The Naked Scientist people can listen to. And this person in America said, I got really into this program. I listened to about 3 or 4 hours of it every day, working my way through the catalogue. I knew I'd overdone it when I began to dream with an English accent. And so, because we're exporting cultures like this and language and ways of speaking, people do begin to adopt and pick up and incorporate and mimic and ape words. And so I think there is going to be a blurring of accents. Accents possibly have had their day, and these big boundaries are probably going to slip away a little bit more as people embrace more, especially in the English-speaking world. In the non-English-speaking world, maybe a bit different, but in the English-speaking world, I think there is going to be a bigger blurring of these boundaries.
702 and Cape Talk.
The Naked Scientist.
23 minutes after 10. A couple more of your questions. Ross, thank you so much for holding on.
Hello, yeah. I want to ask another question about light. The other day I was driving home, and oncoming headlights were, of course, giving a certain amount of dazzle. And it doesn't come at you as a cone of light, though. It seems to be changed, and the intensity of the light seems to change. If one looks at it as the sort of face of a clock, I find the intensity of the light comes from 2 o'clock and 7 o'clock. And I just wondered why it was that dazzle doesn't seem to be evenly distributed around the source of the light.
Hello, Ross. The answer here is that the manufacturer of the car wants to make sure that they illuminate the way ahead optimally without wasting light on illuminating things you don't need to look at. So they try to achieve a degree of focusing of the light, and this is achieved by the reflector behind the bulb. So the back of the light casement inside the car is a silver surface which reflects the light. It's a mirror. This is shaped and uses various aspects of the shape to bend the path of the light or to angle the light so that it casts the greatest intensity of light where it thinks you need to look. Also, on some cars, the actual glass that the light comes through, or the plastic that the light comes through on the front of the light casement, also has a focusing effect to an extent. So both of those effects contribute. Also, if the person doesn't dip their beams, in front of the main filament on the bulb's dipped element is a small piece of metal so that the light doesn't hit you straight in the eye when the beams are dipped, but when they're on main beam, the light can come straight out at you. So all of these things work together to produce effectively a cone of light that illuminates the road ahead, albeit shared between two sets of headlights.
Roger, good morning to you.
Yes, I have a quick question just around in science fiction. Space travel happens at warp speed and moving through warp. But is a warp drive actually possible, and how would it work?
Okay, well, the reason they call it warp is because the idea is that space is huge. The universe is enormous. It's literally, billions of light years across, and you don't have that long in a human lifetime to travel. So rather than try to go faster than the speed of light, which Einstein says is impossible. Light is a finite speed, 300,000 kilometers per second. You can't go faster than that. So if you can't break the speed of light, then the other way to get from A to B over a vast distance is to actually bend space or warp space. So the idea is that if you had 2 points, A and B, and they're a vast distance apart, instead of trying to go as the crow flies between A and B, if you had a sheet of paper and you held it one end and the other end and you bent the sheet of paper around so the two edges came together in between two sets of fingers, then you've warped space and you've made the distance between A and B much shorter. Now, theoretically, you could do that, and as one theoretical physicist said to me, I'm always a bit sceptical about theoretical physics because with maths you can prove anything. So theoretically, you could potentially bend space. Whether it's realistic as a principle for travel, I really don't know. I don't think anyone does know at the moment. But what we do know is that if you did try to do that, it would take vast amounts of energy. So until we're in a position to be able to produce enormous amounts of energy or to use gravity in order to bend space and produce what people call wormholes or something, which effectively amount to the same thing, then I don't think we're going to be seeing a warp drive anytime soon.
Georgette, our final question. What is yours for Chris?
Yes. Dr. Smith, do you have an eidetic memory?
I've forgotten. Yeah, I spend a lot of time reading things, and I'm very privileged because I get to talk to some of the most intelligent people on the planet every week because I go and interview them for the programs we make. And so I look upon it that I've had one of the world's best scientific educations because these people talk to me for 15, 20 minutes about the study they've just done. And if I didn't learn something from that, then I would be a very, very poor intellect, wouldn't I? So I'm the beneficiary of a hugely good education from all these wonderful people who talk to me each week. So I've picked up a few things along the way, and I'm lucky to have a good memory so I can store it all away.
More than just a few things you've picked up, Chris. Thanks for your generosity. We'll do it again next week.
All right, see you soon, everybody. Bye-bye.
Cheerio.